again, complex numbers, whoop-de-doo, they have an I, you know what to do. We're going to gather together like terms. Everybody should be on this page, by the way. So we're going to gather together. Here's your real part and your real part. Add those together. They're the only things without an I. What do you get? 14. If we're having trouble doing 8 and 6, go to the calculator. Come on, people. I know you can do better than that. Next, you're going to take your imaginary parts. Make sure you watch the sign. That is a -3. Put them together. What do you get? Plus 2i. That, ladies and gents, is your answer.
So you can add those?
Yes, it's just like adding like terms. You're adding together the real parts, add together the imaginary parts, you get a new complex number. That is the sum of that complex number plus that complex number.
Okay.
Now, next question that might come up, does the order matter in which way we write this? Yes. When you write this, you write the real part first. Always comes first. Now, sometimes you might not have a real part. It might just X itself out and cancel out. Sometimes you might have an imaginary part. But the real part comes first.
So in real life, this is like 14. That's it?
No. It is a complex number that has 14 plus 2 i's. It has an imaginary part to it. All right, let's subtract them. To subtract them, it's just like when we subtracted polynomials. There is a minus sign in here, but we're going to make our life easier by doing what? Yep, we're going to change that to a plus. We're going to make this addition, but how do we compensate for that to make sure that we're still doing the same thing? Guys? Yeah, we're going to change every sign in that second parenthesis. The parentheses that is in front of the negative, then that changes to a -6, that changes to a -9. Remember, because subtraction is the same as adding an opposite. You've now changed this to an addition problem. So now it's the same as it was before. Find the real parts. Add them together. What do we get? -1. Then, find your imaginary parts. 11i. Real part first, imaginary part next. Guess what? That's the answer.
No way.
All right, so we can't have this negative under the square root. So let's go back and now, this is our two major concepts that you're going to learn today. The first one is we got to deal with the negative underneath the square root. So first thing we're going to do is rewrite that as -1 times 12. And we're doing this just like we pulled out those perfect squares. We're going to pull out that square root of -1 and we're going to replace it with the definition that we've learned. What is the square root of -1? So I'm going to take this and rewrite it. Square root of -1 times square root of 12. And then this right here, what does it become? What have you learned today? I. You got it. So it becomes I squared roots of 12. And again, that I is just indicating that you're dealing with an imaginary number. That I is allowing you now to go back to what you already know now. Because can we do some work on the square root of 12?
Yes.
Yes. Now it goes back to our division. And 12 is divisible by? 2. Half of 2 is?
6.
6.
Half of that is 3.
And then 3 gets divisible by? 3 and leaves you with?
1.
1. Again, we're looking for square roots. So we're looking for any number that repeats itself twice, which is there. So notice I just gets to linger along. All right, so square root of 2 squared times 3. What's going to happen to that square root and that 2 squared? Yep, they separate. Got to keep them separated. Sorry.
Nice.
Thanks, old school.
That was a funny thing.
And the square and square root do what?
The 2 goes out.
Now, where are you going to put that 2?
On the outside next to the I.
In front of the I or after the I?
In front.
Yeah.
Oh, I did it.
2i square roots of 3.
I did it right originally.
You should not be surprised by yourself. I know you guys can do it. This is just a new layer onto what you already know how to do. All right, ladies and gents. Here's how to make your life easy. Well, I need you to recognize something. As soon as you see that negative under the square root, instead of going through the whole process of rewriting it, what is it going to become?
1.
An I. It's going to become an I. You can save yourself a little bit of time and effort. And anytime you see a negative under a even root, this doesn't work for cube roots, but square roots, you can just go from the negative underneath to the I out in front, and you've skipped that step. Are you still doing what you need to do? Yes, you've just kind of skipped that middleman step of doing square root of negative 1 times 16, square root of negative 1 times the square root of 16. And we've just gone right to here. Again, the negative comes out not as a negative sign, as an I. Now, I hope we're not struggling with this. You do not need to do any work. You need to know the square root of 16 like this. Quick. What is it? 4. So now you have a 3 times an I times a 4. That is not your answer. Yes. Multiply. This is a multiplication problem. You can multiply in any order that you want. Your answer is 12i. All right. So then we get to the next one. Let's shortcut. Make our life easy. What can I do with that negative right now to make life easy? I. Bring the I out. The negative sign disappears. Bring the I out. The negative sign disappears. When you have that negative in the square root, it means an imaginary number. You are replacing that. It's a substitution idea. And now you're left with this. All right. Now we got a little bit of work ahead of us. What can I do with the I times the I? Is it 2i? Is it I squared, or is it 2i squared?
2i squared.
It's I squared. Ladies and gents, there's nothing being multiplied in front of the i's. This is a multiplication problem. This is I times I, which is I squared. Not a 2. Now, what can you do with the square root of 10 and the square root of 2? Can I combine them together?
Yes.
Yes, because it's multiply. What do you get? Square root of 20. Hey, guess what we get to do now?
We get to do
The line thingy. So 20 is divisible by
2.
2.
Which is 10.
We got
And you do 2, then it's 5. And then you do 5, then it's 1.
Sweet.
Wouldn't it have been easier not to combine them since 2 is already a prime number?
I could have done that too. Did it work?
Yeah.
Okay, perfect. So this becomes I squared, square root of 2 squared, times the square root of 5. What's going to happen here?
Cancel each other out. 2's.
So I get 2, yep.
Yes?
I squared, square root of 5. Now, here's where we're going to hold for a moment. This answer is good, but this answer is not done.
What do you mean not done?
Exactly. What do I mean not done? That since we were not done, again, you're going to just remind me, what did we replace I squared with?
Negative 1.
Negative 1. So, yes, I am. I have been. That's your final answer. Okay. So now we can multiply complex numbers. We're going to use our newfound information to help us out. You have already multiplied for me. If you look at your notes, what did I say we're going to use? The box. And I even boxed it for you so that you do not forget that you're going to box this. This is just like multiplying polynomials. There is no difference except instead of dealing with x's, we're dealing with i's, and we know i's are representing complex numbers. So again, 2 by 2's. And since complex numbers always consist of a real part and imaginary part, the good news for you is you will never have more than a 2 by 2.
6.
Okay. So now let's multiply like you've always done. 2 times 3 gives you 6. 5i and 3 gives you 15i. Yes, you're allowed to multiply things that are not like terms. 2 and 7i gives you 14i. What about 5i and 7i? Thank you for the I squared. Yes, an I times an I gives you I squared.
You did 15, it's 14.
Ooh, I did. Thank you.
Then we'll put like...
It's like it never happened. There we go. Change that. I said 14, wrote 15. Now, hold up. If we were doing this like we did before, and that it is no real difference here, you probably wouldn't have written out 35i squared. How many i's are there? 19, 29, 29.
Don't do that because the imaginary number goes last. You said so.
Hold on.
Yeah.
Yeah.
Alex, have a little bit of patience.
Not right.
All right. Now, a complex number, ladies and gents, if you're multiplying, adding, or subtracting complex numbers, you should get a complex number as a result. Complex number has a real part and an imaginary part. This has too many parts. That's one of your clues that you need to do a little bit more work. Next, this is what you know to pay attention to. I see an I squared. What do we need to replace with the I squared? So you're going to multiply that negative 1 times 35 to get what? All right. Now, do you have any like terms that you can combine?
Yes. Negative 35.
Which gives you? Negative 29 plus 29i. That's your final answer. So the important part of this is you understanding right here that that I squared gives you that negative 1. That's going to change your values. All right, so what I want you doing